What's up, everybody? Hope you guys are doing well. I got a special guest today that I will be doing a quick interview with. So, meet my brother. Ugh, that hair though. Let's go into
What's
studio.
up, guys?
All right, so this is Kai. He's my younger brother. First question for you, Kai. Um, what's going on with your hair? Is that your natural hair color?
Actually, I got bored in quarantine.
Okay, happens to the best of us.
Yeah.
Second question for you, Kai. If you hit yourself and it hurts, does that mean you're really weak or really strong?
Really strong.
Really strong. Okay, yeah. All right, next question. I want you to take this piece of paper, do it for everybody can see, and then rip it right down the middle. Spell that sound.
Terror.
Last question for real. Okay, I'm gonna give you 3 letters,
Okay.
and you have to say what it sounds like. Okay.
Okay.
So first go around is TWA. What does that spell?
Twa.
TWE.
Twee.
TWO.
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 What?
Twelve.
TWO. What does that spell?
Two. I don't get it.
Do we have a pen? All right. TWO. What does that spell?
2.
All right, that's it from
That's
us.
the stupidest thing.
See ya. Okay, so for section 4-5B, we're looking at our exponential and logarithmic equations, but we're going to be looking at how to solve them if I have an inequality in the equation, and how can I solve these by graphing. So we're going to start with our inequalities and turn that into graphing as well. So say that I had log base 10, because remember common logarithm, not written so it's 10. Log base 10 of x minus log base 10 of 2 is less than or equal to log base 10 of 75. So how would I solve this? Well, remember when we have our subtraction, using our logarithms, it's the same thing as dividing. So I can rewrite this as log of x over 2 as I divide those two. It's going to be less than or equal to log of 75. Now what we can do next is raise everything to, since the base is 10, I can take 10, make that the base, and it's raised to this, like so. So make the logarithm the exponent, and since they both have the same number right there, the logarithm and the 10, they cancel out, and I'm left with x over 2 is less than or equal to 75, and now it's just basic algebra. Multiply both sides by 2, and you get x is less than or equal to 150. And that's my answer. Now, a few things we got to make sure of. Remember, if you multiply or divide by a negative, and you flip the inequality. And then also our, since log of x, I have to make sure that x is not 0. It has to be greater than 0. So we could also say that x has to be greater than greater than 0. So that's how you would solve these using your algebra, your inequality solving algebra. It's basically the same thing. You're just dealing with the inequality. But now let's go ahead and look at how to solve exponential and logarithmic equations using our graph and our graphing calculators. Alright, so let's look at how to graph these logarithms, this inequality, and find the solution using our graphing calculator. So I'm going to split this up into two equations. I have my left-hand side of the equation and I have my right-hand side of the equation. Let's say this is y2, let's say that this is y1. So these two equations are going to be what I enter into my graphing calculator. So my graphing calculator is going to hit y equals. I already have it entered, but y1 is going to be the top one. I'll do it with you guys. So I hit log of, what was it, x? Yeah, x, close parenthesis, log of x, close parenthesis. Really make sure that you use your parentheses there. It's important. Minus log of 2, close parenthesis. That's my first one. Second one is log of 75, close parenthesis. Now I hit graph, and I'm going to hit zoom 6 standard. So there's the graph that we're looking at. Now we're going to be looking for the intersection between both of these graphs. The intersection is where both graphs are equal, and that will give me, since I'm looking for less than or equal to, I'm going to be looking for where one graph is, the blue one is going to be below the red one. Now the easiest way to do this, let's just go into second graph, get the XY table, and let's just look for when both my Y column and my Y2 column, when they're both equal. So let's have 3.1 or 1.3802, and then I have 1.875. So let's just scroll down until both of these are the same. So 1.56, 1.7, 1.8, 567. So we have 1.8692, 1.8722, and then right here, know that these two are equal. So my solution is going to be 150. So looking at the XY table, I'd say that X, now the graph, when we look at the graph, notice it's below it. So X, and how I can tell that is that this graph here, the X minus log of 2, log of X minus log of 2, that is below log of 75. So here's log of 75, here's log of X minus log of 2, and we're saying that we're looking for the solutions below X is less than or equal to that. So X is less than or equal to 150 due to this number right there. So that's the first way I can check it. The second way is, let's go back to our graph. Alright, so knowing where, from the table, knowing where the intersection is going to take place, I can also use my intersection feature on the calculator. But I do have to change the perspective that I'm looking at. So let's change my X minimum. That's the horizontal minimum. Let's go ahead and change that to, let's just do 140. Maximum, let's do 160. And then let's do for X scale, that stands for how many units you're going by. Let's just change my Y minimum and Y maximum. Let's just see where we're at on that. Okay, so it's pretty close. Okay, so let's just try this. Let's see if it works. I'm going to hit second, trace, 5 intersect. Now first curve is the blue one. That's my first equation I entered. Red is my second one. Now I have to guess. So I'm just going to guess. Notice I can move this around and guess wherever. So we know what the answer is, but I'm going to guess right there. And that gives me my intersection value, that 150. So you can use the intersection feature on your calculator to get the intersection. The only difficult thing is that when you look at the graph, you're going to have to figure out where the intersection is, and that might be kind of hard, especially if you're looking for it. You might have to move around a little bit, change the zoom, maybe zoom in, zoom out, and whatnot. But that's how you do that. I would suggest maybe on smaller numbers, just use the table and look for when both numbers are the same. Let's do another example. Let's look at an exponential equation. Let's say that I had 2 raised to the 2x equals, not an inequality, 1024. So again, I'm going to change this into a left-hand side of the equation and the right-hand side of the equation. I'm going to enter both of these into my calculator. That'll be y2, this will be y1. So set y equals, let's clear all this out. Now I'm going to do 2 raised to the 2x. That's my exponential equation. And I'm just going to do 1024. It's going to be a horizontal line. So I graph it. I don't see 1024 because that's way up here. Way up here. So I'm going to do zoom. Let me zoom 0, zoom fit. And notice that my blue line is here. My red line's right down there. So that's where both graphs are. Let's go back to our normal function. Set second graph. Now I get my XY table. Now I need both these numbers to be the same. Now I'm at way high, I'm at 150, so let's go back to 0 and just see what we have. Okay. So since this is an exponential, this is going to get high really fast. So I have 1, 4. I need this column to equal this column. So as we start going higher, right there, there's my two numbers, 1024, 1024. So my answer is 5. So that is how I can solve this using my graphing calculator. I graph it and just look for where the two graphs intersect. Now, using, I'm going to zoom out a little bit. So zoom 3, zoom out. And do it again. Maybe again. Okay. So here you can clearly see where the intersection occurs. It's just so far out you can't put them all together because this is 1,024 units up. So let's try second trace, 5. That gives me the intersection feature. I hit my first curve, second curve, and my guess, I can see that they come together right there, so I guess, and it gives me the intersection. So both methods work fine. Sometimes it'll be hard to find where the two graphs actually intersect. You might have to do a little bit of messing with your parameters on your calculator, but that's the two methods that you can use to get that answer. Now you could also do this by just using algebra. If you prefer that way, that's fine, but this is another feature that you can use on your calculator. Alright, so that's all for today. Hope you guys have a great weekend, and let me know if you guys have questions. See ya.